a couple of lessons ago, the concept of a projection of one vector onto another, and it's the magnitude of that projection, known as the component, were studied. And the way that worked is you might have like a vector like this, and a vector going like that. And if this is u, and this is v, then if I draw a sort of perpendicular like that, then this red vector is the projection of u onto v, and the magnitude of that is known as the component of u in the direction of v. Well, this idea of the component is going to come up in a physics application, and it goes like this. Here is a ramp which has a 15-degree, set it like an angle of 15 degrees, and there is a car on the ramp. Now the car weighs 3,000 pounds, and the way we illustrate that is from the center of the car, we draw straight down towards the center of the earth a vector, and that's a vector, I'm going to call it 0, negative 3,000. That's gravity, that's the force of gravity, because that's the weight of the car is 3,000 pounds, and the magnitude is just 3,000. Now, I can split this vector up by doing a projection. By projecting this, so the car is going to try to go down the ramp, and there's going to be a force pulling the car down the ramp. And the way that works is that there's a force going like this in the direction of the ramp. We want to know how big is that force. By drawing this perpendicular line, it's perpendicular right here, that's a right angle, right there. It's a little hard to see. Let me erase this wheel to make it easier to see. Whoops, there's too much erasing. This red vector is the projection of the gravity vector to this vector in the direction that the ramp is going. But if I complete this entire rectangle, this gravity vector is basically the diagonal of this rectangle. It's got the blue side. I'll make this last side black, and I'll make the blue a vector also. So what I've done is I've split up this gravity vector into two perpendicular vectors. One that's sort of parallel to the ramp and one that's perpendicular to the ramp. And those red and blue things, especially their magnitudes, are going to be important. Because if this car weighs 3,000 pounds, in order to stop the car from rolling down the ramp, I need to put a force opposite to whatever the size of this red force is. So I want to know what that red force is. And we have a whole complicated formula for projection if we know the two vectors. But in this case, we know the angle is 15 degrees. That's going to be really useful. Because if this angle is 15 degrees, this big green triangle is going to have, it's a right triangle. So this angle will be 75 degrees. That's also this angle up here. And what I'm looking at is a right triangle with 3,000 as its hypotenuse, 75 is this angle, and we want to know the magnitude of the red, so I just do 3,000 cosine 75, and I get 776. So this red thing has a magnitude of 776, and that's the amount of force going down the ramp. So if I want to stop this car, I have to push up the ramp in that direction with 776 pounds of force. There's also this blue vector, which is the other component that goes added to the red one, make the gravity vector. So the gravity vector has been split up into these two, the red and the blue. Well, the blue one's important also. Its magnitude is, this angle down here is 15, so its angle could be thought of as 3,000 sine 75 degrees, which is pretty close to 3,000. It's 2898, but officially this is pounds. What that represents is that's the force that the car is exerting on the ramp itself, 2,898. So the ramp doesn't need to be as strong as it would if it's a flat ramp. You can have 3,000 pounds of pressure pushing up against it, but because of this slant, the ramp doesn't need to be quite as strong because it's only going to need to withstand 2,898. That's the force pushing from the car against the ramp in the direction of the perpendicular to the ramp. So those are some questions. Sometimes they tell you other information about this, but that's the basic idea for how the idea of components, which is this is a projection and its magnitude is a component, how components are used in physics.